we have I would say, a jam-packed hour ahead of us, so I'm not going to waste too much time. But first, I'd like to thank all of the speakers today who are going to be presenting on this very important topic. And so, without further ado, I am going to turn it over to John Havens, who is going to give a brief overview of how this standard series and became just actually came into being. So John, if you're ready.
I'm here, and thank you so much. Yep, thank you, Justin and David. Really thrilled and honored to be here. So I am the Executive Director of a program called the IEEE Global Initiative for Ethics of Autonomous and Intelligent Systems. The program started back in 2015, and we launched a paper called Ethically Aligned Design in December of 2016, version 1. Version 2 came out last December. And in that paper for version 2, there are 13 different committees focused on areas like personal data, law, etc. And from Ethically Aligned Design, beginning with version 1, there were a lot of ideas from committee members for projects that they felt might make good standards working groups or standardization projects. So we're thrilled that of the 14 P7000 approved working groups, about 12 of them were actually inspired directly from members of the initiative and from Ethically Aligned Design. And so those 14 working groups are in various stages of work on their different projects. And in terms of the focus of all the 7,000 groups, the basic idea is how to prioritize ethical or applied ethical considerations at the front end of design, and also to really inspire and build on the amazing work of engineers since time began in terms of keeping things safe and risk-free, et cetera, to really consider the logic here is to complement what engineers already do so beautifully in terms of safety, et cetera, and say, what are the other questions with autonomous and intelligent systems and how they affect people's agency, emotion, and identity? What are ways to ask new questions that with those answers we can work better to avoid unintended negative consequences while also identifying positive unintended consequences, which is just another word for that is innovation. So anyway, that's the whole inspiration behind the series and sort of a background, a general background. And I'm honored to be the chair of IEEE P7000 and P7010, but today in my role as chair for 7000, I mainly want to introduce our fantastic technical editor, Ali Hassami, who is actually going to walk you through a description of P7000. So thanks again for letting me be here, and Ali, I'll pass it over to you.
Thank you, John. Thank you, David. I have the pleasure and honor of being the technical editor of P7000, the model process for addressing ethical concerns in system design, a standard which I can promise you would have a very far-reaching global impact on how ethics is addressed in any aspects of modern technology. I would give you a quick overview over the next 10 minutes. I'm more than happy to take questions as and when it comes to Q&A time. So without further ado, next please. The purpose of P7000, and I joined roughly a year and a half or so ago in January 2017, is to create a shared understanding and a mission around ethical values, priorities, and how these priorities and values can be impacted by technology, and what is it that as a technical community we can do to preserve and protect our shared values globally as a community. We hope to assure and support engineering establishments who are excellent and competent in system engineering practices and largely so far concerned with safety and environmental aspects, sustainability aspects, to actually end up with a value-based mission and help help them and assist them to understand the ethical dimension to any product, service, or system that they design and put into use globally. Next page. The objectives of the P7000 as an overview is to actually take the ethical value-based or ethically sensitive design processes and extend it into rational process for products, systems, and services. Some of these are, if I can say so, my personal ambitions. So we want to extend the scope to go beyond the specifics of a given technology and how it should be configured to bring value to the society. Now, once we have that generic process, we would use the process to analyze according to various ethical paradigms and philosophies that are in common usage at the moment, as well as hopefully an extension of that in terms of factoring in cultural and ethnic value-based systems and identify what does a product, system, or service affect in terms of the known social values. And then once we identify the values that are going to be affected by that product, process, or system or service, we would go through a risk analysis, identify high impacts and high value social values that we would like to protect, and come up with design features to preserve and even enhance some aspects of ethical values that are going to be impacted by the design and development and deployment of that particular product system. Then go and implement these and verify and validate it against the stakeholder community who have been consulted to derive such values in the first place. Post-implementation, we would like to monitor the performance, because not only that would apply to, if you like, classical design solutions and products, so that when we know all the requirements up front and all the behaviors up front, we would also address emerging issues that may have escaped attention and analysis up front, as well as for systems such as adaptive systems and machine learning based systems that not all behaviors are known up front. Finally, the objective is to provide an audit, conformity verification, and hopefully certification for industry enterprises from small to multinationals, in order to reap the reward of the hard effort that we put in complying with P7000 as a model process. Next, please. Now, in order to briefly understand what the process is going to be for consultation and analysis of ethical values that may be impacted, it's instructive to have a quick look at the principal theories that we have currently in common parlance between philosophers as well as ethicists. One class of belief and ethical theory referred to as consequentialism or utilitarianism, as a subset of that promoted by John Stuart Mill, and it basically looks at the maximum positive impact for the largest number of beneficiaries of an initiative, product, system, service, etc. The other school, so-called the duty school or deontological school, promoted and developed by Immanuel Kant, is the so-called categorical imperative, and it puts the duty on the duty holders to treat themselves as lawmaker and say, what would you do in these circumstances that you're affecting values, and what is your solution for preserving the values? So the top management involvement in personal ethics is relevant here. And finally, even further back in history, the virtue ethics of Aristotle, which basically regards humans and carriers of virtues, and it is question of what is a virtuous behavior. So the reason I'm just briefly introducing the ethical theories is to actually highlight that these constitute the framework through which our analysis of impact on ethical values would take place. Next, please. Now, there are many challenges in delivery of basically virtue, deontological, and utilitarianism type analysis, because each one of these create different KPIs, different outcomes, and it required reasonably inclusive stakeholder involvement. We want to avoid, where possible, putting our own values on top of others in terms of normative ethics. We would like to go beyond the constraints of legal duties, and since many of the ethical concerns are not entirely legal in the sense that people can do what they wish to and still be compliant with the law, but not necessarily with the social values. We need to cover the entire life cycle of initiation to deployment and maintenance and even disposal of products and systems and services, and also recognizing that currently, at least in this space-time, that IEEE Standards Organization, thanks to them, have taken this initiative. There aren't a great deal of legal and regulatory guidelines around. So we are hoping that the P7000 would fill a gap in this space until more regulation hopefully comes around. Next, please. So with that outline in terms of the processes that we would use for identifying and addressing ethical concerns, it's also instructive to have a look at what categories of products and services we have ambition for in falling under the net of P7000, in the purview of P7000. These come from probably large categories of what's often referred to as generic products, systems, and services. These are the ones which are generally aimed at international community, but not a specific domain of application, such as generic platforms, generic medicine, etc. Then we come to generic applications, where a general product is more or less customized for a domain of applications such as medicine, oil exploration, etc. And then we've got specific applications where we know exactly who are the stakeholders, where is the geographic location, and what is the nature of service and functionality and behavior. So it's quite a vast territory to try and cover, but that's the ambition. See how successful we'll be at the end when we draft the standard. Next, please. Now, this is an overview of the structure of the standard. We have a so-called baseline produced around October 2017 by Professor Sarah Spiekermann of Vienna University, where we are basically working as a number of subgroups and specialized groups, developing the baseline draft. Thank you to Sarah and her IEEE colleagues who managed to handcraft the first draft. What you would see on the left-hand side is a little blue cloud which refers to ethnic value system, which I would personally, as a technical editor, need to add to the current structure of the utilitarian virtue and the ontological analysis, just to allow for other forms of social value based on history, culture, religion, or whatever it is, to actually make the standard as wide a scope as possible, because from my perspective, many of these three classes that we refer to may be seen as largely an affluent world's view of philosophy and value system. Next, please. Here's an outline of an attempt that we made to clarify the ethics domain from and its boundary with the engineering domain. So here's an outline, so-called core process or reference model for our work. And Sarah, who is the author of the baseline draft, has endorsed this view. So we are largely going ahead with polishing the draft baseline on the basis of the process model or the reference model that you can see. And it, just for sake of clarity, there are a number of processes that the standard advocates. Some of these exist in the enterprise domain in the sense of management and philosophy and practices, and the rest are in the design, development, and product or system or service realization. So the top part is the ethics domain, and the bottom part is the engineering domain. And the interface is really where we convert our concerns about social values and ethical values into functional and non-functional features that feed into a standard system engineering processes. Next, please. As an outline, here's the organizational structure for our team. We have chair and vice chair. The chair is John Havens, as he introduced himself, and we are really greatly indebted to John's vision and direction for taking us this far. And vice chair is Professor Speakerman, who's not with us. She's on a sabbatical at the moment. I have the honor of being the technical editor and the privilege indeed. Then we have a secretary and a number of specialized subgroups. And if you have competence, expertise, or insight into philosophical domain, social impact domain, social values, or engineering indeed, I very much welcome your interest and participation in any of the ethics, process, risk, system of system, and ontologies subgroups that are currently beavering away, producing the updated version of the baseline draft that we are very much ambitious about, and hope to have a internal draft by towards the end of the year. The working group, the WG, is quite large, currently entertains 56 members, and the style and approach is one of consensus and collective work together. And my work is technically a kind of a system integrator to take the outcome of work from these subgroups and integrate them into a coherent and consistent second draft of the standard. Next, please. Now, where would this standard come in, and what is the impact or anticipated impact on the industry? We, as I have alluded to, are ambitious to make this standard as generic and widely applicable as possible. We are also hoping that it would be the same standard and the standard processes that would cover classical and modern adaptive sort of emergent property systems. So we wouldn't have one for classical old-fashioned software or system design and one for AI-based machine learning type variation. We hope our processes would address all of these. We're also hoping that practitioners and adopters of the standard would be able to use sort of independent audit organizations to audit conformity with the standard once it's issued in the open, and hopefully end up with certification. And part of my ambition also is that it shouldn't ideally be entirely about brand new products. If possible, we try and steer it towards being able to be applied to redesign and system upgrades and enhancements, so that aspects of ethical conformity can be gradually grafted on, even on legacy systems. That's a great sort of grand ambition. Whether we achieve that is hopefully to be seen. And as we have already said, we would very much like to ensure that the scope of application is product, system, and service, not just artifacts that are of physical presence and appearance. Thank you. Next, please. So, where are we today with respect to technology? We find that our destiny as a global community through globalization and civilization and technology is increasingly intertwined. We basically live close and impact on each other's life, well-being, and prosperity. So what seems to be the challenge is that the public good has not been viewed to actually sit comfortably alongside commercial gains and imperatives that enterprises follow, and we hope to be able to convince people that these coexist, and they potentially also impact the bottom line in the sense that if you care for the public good, and there is research to support this perspective, at least coming from the financial services industry, that those who actually have a public good in mind and socially responsible attitude seems to benefit actually in terms of bottom line impact, at least during times of stress. The technologies, especially some of the modern ones such as AI and autonomous systems, seem to present challenges that are not easily addressed by existing regulations in many developed and developing countries, largely because most of the regulations apply to preservation of health and welfare, but not to our ethical, cultural, and value system. So this is where we are stepping in and filling that gap with P7000. And really the mindset is go beyond just fulfilling minimal legal requirements and provide a setting where you could show to your consumers, to your stakeholders, to your clients that you, as an enterprise, as a service or product or a developer and provider, care for the social impact. So the answer to all of this is to have a reasonably comprehensive, coherent, and hopefully as wide a scope as possible global systems approach, and that's what we are hoping to achieve through P7000. Thank you very much for your attention, and I very much welcome your interest in joining us and contributing to this global initiative.
Thank you very much, Professor. I appreciate your presentation. The information is, I'm sure, very beneficial for everybody. Before we move on to P7001, I would just like to again remind everybody if there are any chat via technical issues or questions for the speakers, please chat them directly to me, Justin Queso, because we were having some small difficulties with the chat feature for David. So again, just please send them all to me. And with that, we're going to move on to 7001, and I'm going to turn it over to Alan.
Thank you, David. Is this volume okay?
Yes, it is.
Great. I'm delighted to be here, and it's a great pleasure to introduce P7001, Transparency in Autonomous Systems. So if we go to the next slide, please. So who are we and where are we in the process? Well, I have a wonderful team with Nell Watson as Vice Chair, Takashi Igawa, Secretary, great support from the IEEE, Michael Kipnis. We currently have 26 members of the working group, although actually in the last few days we've had a few more asked to join, so I think we're up to around 30. And we're about 18 months into the process, and we're targeting fairly confidently the first draft in January 2019. And just, you might be interested to know that we had our second face-to-face meeting just last week, exactly a week ago, in our lab in Bristol Robotics Lab. Thank you. So what do we mean by transparency? Well, transparency, a robot is said to be transparent if it's possible to find out why it behaves in a certain way. So we might, for instance, want to discover why it made a particular decision, especially if that decision caused an accident. or perhaps for the less serious reason that the robot or AI's behavior is puzzling. Now, in the context of autonomous and intelligent systems, transparency is a property which those systems might have more or less of. In other words, if there are measurable, testable levels of transparency. So it's important to understand, of course, that these properties are not intrinsic to robots and AIs, but they must be designed for. And of course, sometimes transparency might be difficult to design in, for instance, in systems based on artificial neural networks or systems that are continually learning. Thank you. So why is transparency important? Well, really, there are two reasons. First, because modern robots and AIs are designed to work with and alongside humans who need to be able to understand what they are doing and why. Imagine a care robot that behaves in a way that's puzzling or unpredictable. An elderly person is unlikely to trust the robot and therefore not get the best use from it. So transparency is important in building trust. The second reason is because robots and AIs can and do go wrong. If physical robots go wrong, they can cause physical harm or injury. Even a software AI can cause harm. A medical diagnosis AI might, for instance, give the wrong diagnosis, or a credit scoring AI might make a mistake and cause someone's loan application to be rejected. Without transparency, finding out what went wrong and why is extremely difficult and may, in some cases, be impossible. Next slide, thank you. Next slide. Okay, thank you. So transparency is not one thing. It's clear that your elderly relative doesn't require the same level of understanding of her care robot as the engineer who repairs it. Nor would you expect the same appreciation of the reasons a medical diagnosis AI recommends a particular course of treatment as your doctor. Now, broadly, there are 5 distinct stakeholders, and we've grouped those into 2, if you like, overall groupings. So there are expert stakeholders. They may not be experts in robotics and AI, but they are nevertheless experts. And there are non-expert stakeholders. So what I'm going to do now is to look very briefly at the transparency needs of each of those 5 groups. So next slide, please. So the first group of expert users, if you like, beneficiaries of the standard, are safety certifiers. So clearly for them, transparency is important because it exposes the system's processes for independent certification. Now, clearly the type and level of evidence required to satisfy a certification agency or regulator that a system is safe and fit for purpose depends on how critical the system is. The driverless car autopilot should require, of course, a much higher standard of safety certification than, say, a conversational AI, since a fault in a chatbot is unlikely to endanger life. And of course, safe and correct behavior is tested by verification and fitness for purpose by validation. Put very simply, verification asks, is this system right? And validation asks, is this the right system? Next slide, please. So, transparency for accident investigators. So clearly robots and AIs can and do go wrong. And of course, it's very important we can find out why. And driverless cars provide us with a very topical example of why transparency for accident investigation is so important. May 2016 saw the world's first driverless car fatality when the autopilot of Joshua Brown's Tesla Model S failed to perceive the trailer crossing the highway in front of it. The accident, of course, was investigated by the US National Transport Safety Board, and we know from the NTSB report that the Tesla was fitted with a proprietary data logging system, which revealed to accident investigators that Mr. Brown's hands had barely touched the steering wheel in the 37 minutes prior to the crash. But an investigator also noted that the data in that log showed that detection of the truck that the car collided with did not occur, but was not sufficient to let us know why. So clearly there was a transparency deficit. And it's clear that stronger standards of transparency are needed. Now, an excellent model of good practice exists, of course, in the well-established and trusted processes of air accident investigation. Processes, of course, that without doubt contributed to the extraordinary safety record of modern commercial air travel. Notably, air accident investigation agencies have a culture of learning and data sharing across the industry, something that sadly we don't see yet in autonomous systems generally. Next slide, please. I just wanted to share with you a proposal for what we call an ethical black box. So a fully transparent autonomous system would allow accident investigators to discover not only how, but also why an accident occurred. And key to that transparency is the equivalent, if you like, the robot equivalent of an aircraft flight data recorder. We call this an ethical black box simply because it would be unethical not to have one. And in the recent paper, you see the reference here, we argued the case for such an ethical black box. And our proposition is very simple indeed, which is that all robots and some AIs, including driverless cars, should be equipped by law with a standard device which continuously records a time-stamped log of the internal state of the system, key decisions, and sampled input or sensor data. Next slide, please. Our third group of experts are lawyers and expert witnesses, who, of course, may be required to give evidence in an inquiry or court case, perhaps to determine insurance settlements, and, of course, need transparency to inform their evidence. Now, I won't go into any more detail, but you can see that they will draw upon quite a lot of information about, for instance, the process, the quality of the processes that were used in the design of the system. And those processes could, for instance, include P7000, which we've just heard about. Next slide, please. Our category now of non-expert users includes, firstly, users of the system. And, of course, transparency, or to be more precise, explainability is important because it builds trust in the system. So if we take a care robot as an example, transparency means the user can understand what the robot might do in different circumstances. An elderly person might be very unsure about robots, so it's important that a robot is helpful, predictable, never does anything that frightens her, and above all, safe. And it should be easy for her to learn what the robot does and why in different circumstances. So an explainer system allows her to ask the robot, why did you just do that? And receive a simple natural language explanation would be very helpful in providing that kind of transparency. Next slide, please. And of course, then there's a larger category of the wider public, society at large. And that, of course, includes not only the whole of society, but bystanders, people who are perhaps not users of the AI or autonomous system, but are in the vicinity. And it's very important that the whole of society needs a basic level of understanding of how these systems work, so that we can confidently share our work and public spaces with them. And of course, that understanding is also needed to inform public debates and hence policy on which robots and AIs are acceptable, which are not, and how they should be regulated. And next slide, please. And really just a final slide to sum up. Transparency is not something that can be assumed. I think I said at the beginning that it needs to be designed into autonomous and intelligent systems, and the processes by which they are designed validated and operated. And we need ways of testing, measuring, and comparing different levels of transparency in different systems. And those are exactly what we're defining in P7001. And broadly, we need three parallel approaches. So we need process standards for transparency. That's human process for transparently designing, validating, and operating these systems. Secondly, we need technical standards for transparency, and that includes, of course, P7001. And thirdly, we need technologies for transparency. And the ethical black box that I mentioned very briefly earlier is one example of a transparency technology. Thank you very much indeed for listening. I'll be very pleased to answer questions.
Thank you very much, Professor. It's a very important given the awareness that's going on in the public about the transparency behind all of this technology, and the work you're doing is excellent. I would love to ask you a couple questions, but in the interest of time, we're going to move on to P7007, and Edson is going to be presenting on this standard project. Thank you.
Thank you so much, Justin. Are you listening? Is it okay?
Yes, you're all.
Ah, that's great. That's perfect. Thanks so much. It's a great pleasure to be here and talking about the 7007 working group. Next slide, please. The scope or the proposal of this work group is to create a set of ontology that will represent the knowledge, the knowledge that encompass in the robotics automation domain regarding to ethics. So this ontology will be used in different ways, and it will also have different levels of knowledge. Next slide, please. So why ontological standard is important for us? Most of the standards that are published in standard organization are expressed in natural language. Natural language is quite important for us to provide definition, but it also contains a lot of ambiguities. So sometimes some concepts could be understood in a different way by different persons. In that case, in case of ontology itself, it provides a way to analyze the definitions and also to eliminate this ambiguity, because all the concepts and also the relationship among these concepts are expressed using logics. So using logics, you can validate the knowledge represented, and also to check any kind of inconsistency that may appear. So ontologies allows to capture and represent consensus knowledge. So to create an ontology, you have a methodology that allows to elicit all the relevant knowledge on a specific domain, and also allows to represent the knowledge in a formal way, as I commented before. So all the knowledge is represented using, for instance, first order logic. That's quite important to check the ambiguity, inconsistency of this knowledge. One important point is that you do not have only a simple taxonomy. So some people think that ontology, you create only a taxonomy. No, the ontology provides a much rich kind of formation. So you have the taxonomy itself, but you have also some other definitions, some semantics involved in that taxonomy. And one is very important point is that you can use this ontology to create systems. So all this representation could be implemented in a software computer. Next slide, please. So why ontologies matter? This definition of the robot is a quite interesting example that we faced in the past. So Here you see the robot as an actuated mechanism programmable in two or more axes with a degree of autonomy, moving within its environment to perform independent tasks. That's the definition that we faced in one document some years ago. So in that case, when an actuated mechanism becomes a robot, observe that definition is expressed in natural language. It contains some ambiguity in that concept. So when you buy an actuated mechanism, you are buying a robot? According to that definition, no, because to be a robot is necessary to have this actuated mechanism is necessary to have some degree of autonomy. Another question, what is the minimal degree of autonomy that an actuated mechanism should have to be considered as a robot? A reactivity robot that only performs a specific action according to a simple input could be considered as a robot. Observe that this question can be raised in other subdomains, like a landmine is an autonomous little weapon. Observe that landmine blow up when you step over. So could be. But how complex is our domain for be represented in this ontology? Observe that it's pretty complex, because if you think even a simple interaction among the robot and the person, if you want this interaction to be as smooth as possible, you need to pay attention to several dimensions, like robots should communicate with the human properly using language in paralanguage communication. Should be considered also the cultural aspects, hard norms, soft norms. We should pay attention also to elements in the environment where the robot and the human is interacting. So it's a pretty complex. And for us, you want to study this domain and you want to list all this relevant information that surrounds this kind of communication. You should also consider that the interaction among the robots will be observed by a person, for instance, and this person could learn from this interaction, thinking about a small children that is seeing how the robots communicate. In that figure, you can also change the whole of this person. Instead of consider a natural person, but you could consider also a legal person, like a company. So what should be the interaction or the effect of the interaction among these robots in that particular company? Next slide, please. Besides the elements that I commented before, you need to also to consider some set of values that are very important to us, like human welfare, privacy, freedom from bias, autonomy, trust, informed consent, and accountability. So for the 7007 work group, we aim to create an ontology that encompasses all these previous elements and also these elements that is shown in that particular slide. Next slide, please. When you have everything modeled, we can also make a relationship about this basic components, and you can also identify potential ethical issues. So we already analyze the domain, we make connections among these basic concepts. We can, after that, try to how to circumvent the ethical issue, generating solutions. Next slide, please. With this model, you can also answer questions like what are the ethical issues, how to address them, what values are involved in these issues, what norms are being violated, how can implement a solution, how the solution issue impacts the environment, and so on. observe that all these questions could be questions that you implemented in the software computer, because the ontology could be implemented in computer. So you can make some reasoning using this knowledge. Next slide, please. Our work is based on the ontological standard that we published before, called IEEE 1872-2015, where the standard aims to provide a methodology for knowledge representation in reasoning in robotics automation, together with the core ontology for robotics automation domain. So you are using some concepts that are present in the standard to create your own ontology. So any kind of robot that are using this particular standard could be used easily our standard. Next slide, please. That is the standard that we expected to produce in the end. So we have a set of definitions, we have some diagrams, we have some axioms. So in our standard, in your case, you intend also to have some use case, implementation, and so on. Next slide, please. So for that particular standard, you receive an award, the Emerging Technology Award, and also you were cited in the National Artificial Intelligence Research and Development Strategic Plan. Because this standard, I see this standard as a seed for the Industry 4.0, because that enable the machine to communicate to each other. So using a common vocabulary or a common knowledge representation. So in that case, the robot could communicate about the environment, about all capabilities, about the actions that are performed or that are able to perform. Next slide, please. In relation to the 7007, the group expectation is that standard should be used as a guide to the design, development, and operation of products and services related to robots and robotic systems with respect to ethics. The possible use would be a guide for teaching ethical design, a reference by policymakers and governments to draft AI-related policies, and a common vocabulary to enable the communication among government agents and other professional bodies around the globe, part of the decision-making, and a framework to create a system that can act ethically. Next slide, please. Currently, you have around 120 members from different parts of the globe. Next slide, please. And these members are allocated in different subgroups. So we have a subgroup that is focused on robotics, another subgroup that is focused on ethical robot design, another one focused on ethical violation management. The next slide, please. One focused on transparency, another in law, data privacy and protection. Next slide, please. We also have some domain-specific subgroups that focus on healthcare and industrial manufacturing. So that is the structure of a working group, and this subgroup working in parallel. Next slide, please. I list also some standard activities that are based on the 1872-2015 that is called the Robotask Representation in Autonomous Vehicles Ontology. Next slide, please. If you want to join this working group, please send me a message. Our next meeting will happen this week on Friday, 2 p.m. UTC. If you want to join us, please feel free. You'll be very welcome. So, thank you so much, Justin.
Thank you very much. I really appreciate it. as all of the other speakers so far. It's so informative, and I appreciate it. I wish I had time to ask you some questions, but with the interest of time, I have to move on to P7009 with Sandeep.
Hi, can you hear me?
Your audio is excellent, thank you.
Okay, great. So luckily I prepared about 5-6 slides, so hopefully we won't go over the hour. So this is an introduction to standard P7009 on the fail-safe design of autonomous and semi-autonomous systems, and this is an ongoing working group effort. We are very lucky to have incredible experts giving amazing contributions, and I would like to share with you a little bit about what we're doing today. Next slide, please. So the scope of the standard is to establish a practical technical baseline of specific methodologies and tools for the development, implementation, and use of effective fail-safe mechanisms in autonomous and semi-autonomous systems. The standard includes, but is not limited to, clear procedures for measuring, testing, and certifying a system's ability to fail safely on a scale from weak to strong, and instructions for improvement in the case of unsatisfactory performance. The standard serves as the basis for developers, as well as users and regulators, to design fail-safe mechanisms in a robust, transparent, and accountable manner. And here I would just like to point that we are very lucky to have all the other standard groups working to define a lot of these very tricky terms. And we are looking forward to using the work to make sure that we really kind of combine as much as possible to create a coherent framework. Next slide, please. So Alan did talk about this before, but kind of what falls under the scope. And I would like to point you to 3 images. So the first one is a person working with what you call a cobot in a factory, where the cobot takes the heavy load so the person can work underneath it. Now imagine what were to happen if the robot failed to shut down and the door will just fall on the worker. On the left side, you see an autonomous vehicle with the driver basically moving to self-driving mode. This is another vulnerability. The minute we give that power to the machine, what happens if the machine fails? Not necessarily because something happened in a malfunction, but also because it was hacked. And then on the third slide on the right, you see a care bot that is carrying a patient. What happens if the robot fails and drops the patient? How are we going to cope with that damage? Next slide, please. So this is really the need for the standard, is the understanding that all systems fail, sometimes in predictable and unpredictable ways. And the problem is that autonomous and semi-autonomous systems which remain operational after an intended or unintended malfunction can disadvantage and harm users, society, and the environment. And let me stop for a minute and say that we oftentimes think about how to build a system and how to make sure it works smoothly, but we don't really think about the end of the process. We don't really think about what happens when we shut the machine down, or that if something happens and it shuts itself down. And this is really the idea of the need for the standard, to make sure that if something happens, there is a fail-safe mechanism to help mitigate that kind of damage. Next slide, please. So we are a fairly young working group. We started meeting in October 2017. We are about to have our 11th remote meeting at the end of August, and I would really welcome everyone here to join if you're interested. We have 29 members representing over 10 countries, and I personally would like to see more countries represented, because I think that this is a very critical standard to develop to make sure that we can get as many industries as possible and many people and policymakers as well. We are now in the process of voting on the standards outline, so there is definitely still time to join and help us shape what it would look like. Thank you. I think you might have 3 minutes for questions now.
Well, thank you very much. And I just have one quick question for you, actually. You know, when you listed the amounts of participants and the diversity of countries and things like that, is your group looking to take into account, you know, different cultural or regional differences when developing specifications?
Oh, yes, definitely. We're really trying to make sure that we integrate representatives from companies that manufacture or basically work on both hardware and software and kind of export to other countries. But we're also trying to get a lot of countries that are importing markets to make sure that they have a good understanding of what fail-safe might look like. So we're definitely trying to catch the tail kind of on both ends. And I think that for the group to have these kind of clashing perspectives, even though there is an agreed upon technical baseline, I think that the implementation will look very different in different countries, and we're looking forward to understanding how to best deal with that.
Thank you so much, because I find that fascinating, and through the webinars I've moderated, that seems to be, I've seen two common themes, and that is that the different groups are working amongst each other and helping each other to create successful standards, and as well as taking into account regional, cultural differences depending on what the standard is actually addressing. With that, I see we're nearly at the end of our hour, and I want to, this is my fourth webinar over the past month on these standards projects, and everybody is working extremely hard to make these successful, and I would like to really encourage people to get involved. And I wanted to just take a moment. First off, I'd like to thank David here, who's been setting all of these up, and it's not an easy job to get everything going, and his assistance and work on this has been excellent. And I'd also really like to give a big thank you to John Havens, who has been on all of the webinars at different times when necessary to present, and he is truly an expert and a leader in this area for IEEE, and it's very appreciated. And so as far as today, I would like to also thank all of the panelists. You all were excellent, informative, and I have a feeling people are going to want to join up pretty soon. And so I'd also like to thank all the participants who took the time as well today for joining the webinar. Hope it was very valuable to you. So with that, we are at the end of the hour. Thank you very much, everybody, and have a great day, evening, night, wherever you may be in the world.